Forget pre-programmed personalities and generic chatbots. What if you could literally sculpt the mind of your AI companion, crafting her emotional intelligence, her sense of humor? Welcome back to iTech Aspirant. In this video, we're unlocking the hidden world of AI personality modules, showing you how to build the ultimate digital partner that's truly one of a kind. Let's first see the demo of our AI companion.
Yay! Let's have ice cream or watch a fun movie.
Perfect. If you want to build your own like this, watch the full video. Let's start without any delay. First, open your browser and search for ZEGOCLOUD. Open their website. I've put all the useful links in the description and comments, so go check them out first. As a developer, we aren't just looking for a simple connection. We need a platform that can handle the heavy lifting of real-time communication while giving us the flexibility to integrate advanced AI. That's why I choose ZEGOCLOUD. Now, click on Login. If you don't have an account, you can sign up. It's very easy. When you sign up, you get 10,000 free minutes, which is amazing for testing. I already have an account, so I'm just logging in. Here, I already have an AI agent project, but I will create a new one just to show you. Click on Create Project. There are many options here, feel free to explore, but today we go with video and voice call because we have to make a voice companion. Click Next. Give your project a name. Then click on Start with UI Kits. You can also go with SDK, but UI Kits are better for now. Once the project is created, select your platform. Now, look at the dashboard. Click on your project. Here we have our app ID, app sign, and server secret. We just need the app ID and server secret for this project. Make sure don't share these with anyone. Next, click on Service Management. By default, in-app chat is not activated. We need this for the text processing. Click on in-app chat. Click the Activate button. It will show activating, just wait a few moments. Okay, now you see the status is activated. Let's go back to the ZEGOCLOUD homepage. Go to Solutions and click on Conversational AI. Scroll down and click on Documentation. Then click Find Out More. Link is in the description. Here is all the documentation about the AI agent server. Click on Quick Start Voice Call and scroll down. This is the architecture we are building. We will use a Node.js server. If you don't have Node.js installed, just comment Node.js below and I will tell you a very easy way to install it. Below here, click on Register AI Agent to get our API base URL. Now, open your command prompt. Let's create our folders. I prefer using commands because it's faster. First, go to your C drive or wherever you want to save the files. Type this command. This makes our main folder. Now, enter that folder by typing cd and folder name. Next, we create a server folder inside it. And go into it. Now you are inside the server folder. Type this command. This automatically creates our package.json file. Copy your app ID from here and open brackets. I use brackets for this project. You can use Visual Studio Code, Notepad, whatever you like. Open the server folder we just created. You can see the package file is already there. First, let's create a new file. Save it as .env. This file keeps our secrets safe. Inside .env, write ZEGO app ID and paste your app ID from the dashboard. Next, Zego server secret and paste that secret key. For Zego API a base URL, copy the link from the documentation. Find the C in China or general URL. And paste it. Finally, set server URL and port. Save this file. Now open package.json. Let's modify it. First, change the name. Then, add this line. This is important because we will use modern import statements. In scripts, remove the default line and add these two. Finally, replace the dependencies with this list. Axios allows our server to talk to ZEGOCLOUD's server. .env reads our env file so our secrets work. Express creates the web server itself. Nodeman restarts our server automatically whenever we save a file, which saves us a lot of time. Our package is done. Now, create a new file. And save it as tokenhelper.js. This file is very important. It generates the security key that allows our app to connect to ZEGOCLOUD securely. We import crypto. This is a built-in Node.js tool for encryption. This generates a random number. It ensures that every token is unique, so no one can copy an old token and use it again. This creates a random initialization vector. Think of it as a random salt that makes our encryption even stronger. This is our main function. It takes our app ID, user ID, and secret. Here we pack all our data, who the user is, when the token was created. And when it expires, into a JSON object. This line is the magic. It uses a ES256 CBC encryption to lock our data using your server secret. Now, look at these lines. This is where we actually build the physical token. First, we take our encrypted token info and combine all the pieces into one single buffer called encrypt buff. Why 28? Because we need to tell the ZEGOCLOUD server for specific things in a very strict order. We write the expiration timestamp as a big int at the very beginning. This takes up the first 8 bytes. Finally, we use pack.set to drop our actual encrypted message into the box starting at index 28. Here's a typo, now let's convert this. And our token helper is complete and secure. Now that we have our security layer ready, let's build the main server file to register our AI companion. We start by importing our essential tools: Express for the web server, Axios for API calls, Crypto for security, and .env for our secrets. Crucially, we import generate token 0 from the token helper.js we just made, because our server needs to generate unique security keys for both the user and the AI agent so they can join the same room securely. We call .env config to load our variables, set up our Express app to handle JSON, and pull our app ID and server secret from the environment. These are the credentials that prove to ZEGOCLOUD that this is our authorized project. To talk to ZEGOCLOUD's backend, we need to helper functions. First, ZEGO query. This creates a digital signature using a timestamp and a random nonce. This is for security. It prevents anyone from replaying our requests. Next is ZEGO call. This is our universal messenger. It takes our signature, combines it with the API URL, and sends our data to ZEGOCLOUD. If anything goes wrong, it will throw an error and tell us exactly why. Now, we need a function to create our AI personality. Go back to the ZEGOCLOUD documentation. We are going to pull the AI configuration from there. From the ZEGOCLOUD docs, copy the LLM and TTS sections and paste them here. I'll change it from body to agent config to make the code cleaner. For the name, I'm calling her Mara, but you can name her whatever you like. I'm also removing these extra space lines that occurred during the copy-paste so the file looks professional. Next, we need the automatic speech recognition, ASR. Back in the ZEGOCLOUD console. Under Configure ASR, you'll see for types. For this project, I chose Aliungumi because it handles different accents really well, ensuring our Mara understands every word we say. Copy that specific ASR portion and paste it after TTS. And format it. Now in the LLM section, we are using the Dobao 1.5 Pro model. The system prompt is the most important part. This is Mura's brain. Write you are Mara, a friendly companion of, then your name. Keep replies natural, playful, empathetic and sweet under 30 words and use emojis. You can customize this to change her personality. For the TTS text-to-speech, we use ByteDance. I've set the voice type to ZH female 1 which gives her that sweet and high-quality voice. Finally, we call ZEGOCLOUD with the action register agent. This tells ZEGOCLOUD, here's Mara, please save her profile. We save her ID, so we don't have to register her every time. Now we create the route our Android app will call, start call. When you click start in the app, it sends a room ID and user ID. Inside, we get our agent ID. Then create a unique ID for the agent in that room. And use our token helper to generate an agent token. This token is special. It gives the AI agent permission to publish audio and receive our voice. Now, instance config. This is the most critical part of our backend because it defines how Mara connects to our session. First, we pass the agent token we just generated, along with the agent ID and your user ID. This tells the server, this is the specific AI persona we want to launch, and this is the human she is talking to. Inside the RTC object, we link everything together. We provide the room ID and create a unique agent stream ID. Most importantly, we set the user stream ID to match your phone's stream so Mara knows exactly which audio to listen to. We set sync mode 1. This ensures that the conversation history is synchronized between the server and our Android app. In callback config, we set everything to 1. This means our server will receive real-time updates for everything. We set interrupt mode 1. It means if we start talking while Mara is mid-sentence, she will stop immediately and listen to me, making the conversation feel like my perfect companion. Finally, we execute the command. We call ZEGOCLOUD with the action create agent instance. This is the moment Mara is actually born into the digital room. If successful, the server sends back an agent instance ID, which we send to our Android app to confirm everything is ready to go. If there's an error, our catch block will catch it and tell us what went wrong. We also need a simple API token route. This is for our Android app user. It generates a standard ZEGO token so our phone can join the room and start the conversation. Finally, we tell our server to listen on port 8080 and use 0.0.0.0 so it's accessible from our phone over the local Wi-Fi. And our backend is complete. Here you can see all 4 files in our server folder. But before we move on, let's resolve a few small typos to ensure everything runs 100% accurately. First, in our app listen function, make sure you use dots instead of commas for the IP. Next, in our instance config, ensure it's messages. Then, double-check that you've used user stream ID here. Finally, in the callback config, make sure it says interrupted with the correct spelling. And that's it, our security and server layers are now rock solid. Now, let's head over to the ZEGOCLOUD console. In the side menu, change the it from server to Android Java. Even though the example code here is in Java, We are going to write our app in Kotlin. But the SDK works perfectly for both, so you can use whatever you prefer for your platform. In the Quick Start voice call section, scroll down to see these 3 lines of permissions. These are vital because they tell Android that our app needs to access the internet, check the network state, and most importantly, use the microphone to talk to Mara. Now, open your Android Studio and create a new project. Choose Empty Activity and click Next. I'll name this project AI Companion. For the minimum SDK, select Android 8 API 26 or higher to ensure compatibility with modern AI features. Click Finish and wait for the Gradle build to load. Once your project is ready, back to the ZEGOCLOUD console and copy those 3 permission lines. In Android Studio, open your Android manifest.xml and paste them right here, just above the application tag. Now we need to tell Android where to find the ZEGO libraries. Click Integrate the SDK in the console. Copy the Maven line. In your settings.gradle file, paste it under Maven Central. We'll format it for Kotlin DSL like this. Next, we add the actual SDK dependency. Copy the implementation line from ZEGOCLOUD. To get the latest version, check the release notes. Now it is 3.23.1. Open your build.gradle file, scroll down to dependencies, and paste it there, replacing the XYZ with the version number. Go to the Values folder, open themes.xml, and change the theme parent to no action bar to give us a clean, modern UI. Also add the material design dependency as we are using material 3. Now, click Sync Now. Perfect, the error is gone, and our SDK is ready. Time to build the UI. Create a new layout resource directory. Now create a new layout resource file and name it Activity Main. We'll use a relative layout as the root to give us full control over placement. Set the background to a sleek dark color. Add a text view at the top for our title AI Companion. I'll style it with white text, bold weight, and a custom background to make it look like a professional header. Below the heading, we add a scroll view with the ID scroll view. This is important so that when our conversation with Mara gets long, we can scroll through the history. This ensures our chat area stays perfectly between the header and our buttons. Below the scroll view, we create a linear layout for our buttons. Set the width to match parent and height to wrap content. Add the ID. Use this to pin it to the very bottom. We'll set the gravity to center and add some padding so it looks great. Inside this container, we add our 2 image buttons. In Start Call, set width and height to 60 dp. and use a transparent background. For the icon, we'll use the standard IC menu call. There it is, the call button is shown. Now do the same for the stop button. Set width and height to 60 dp. Set the ID to stop call button. And add a start margin to give them some space. For the icon, use IC menu close clear cancel. Now, as you can see, both buttons are shown, but they might look like they are taking too much space. Make sure to cut that scroll view and tag and paste it before the button container. We want the buttons to stay fixed at the bottom, not scroll away. Finally, inside the scroll view, add one more linear layout. Set the width to match parent and height to wrap content. Give it a vertical orientation, add 16 dp of padding, and most importantly, set the ID to chat container. Our layout file is now 100% ready. Now let's start our Kotlin code. First, create a new object file and name it constant. Inside the constant object, we'll define our app ID. Note that we set this as a long type because the ZEGOCLOUD app ID is a high-precision numerical value that exceeds the capacity of a standard integer. Copy your app ID from the ZEGOCLOUD console project configuration and paste it here. Next, we define the server URL. Open your command prompt. Search for ipconfig and copy your IPv4 address. We'll write it as HTTP your IP and 8080. Next, let's move towards main activity. Remove the extra template code first and set the content view to activity main. We need 3 unique identifiers for our session, a user ID with a random number between 1000 and 10,000. A fixed room ID for our AI session, and a stream ID unique to the user. Inside on Create, we link our buttons. First, for the Start Call button, we set a click listener to trigger Start ZEGO. As you can see, this function name is currently showing as red errors in Android Studio because this function don't exist yet. To fix this, let's first create an empty function for Start ZEGO. Now, for the Stop Call button, we do exactly the same thing, but we must use the ID Stop Call button. And then create another empty function for Stop Call. Now, we need audio permissions. We import Android manifest at the top of our file. We check if record audio is granted. Inside the Start ZEGO function, we initialize the ZEGO engine profile. Set your app ID from our constant file. and choose the high-quality chat room scenario. Then, we create the engine. To make our AI conversation sound professional, we enable 3 critical features. First, AC, acoustic echo cancellation. Then AGC, automatic gain control, and ANS, active noise suppression. This ensures Mara doesn't hear her own echo. Finally, we call set handlers and fetch token. Now, let's build the fetch token function. Inside, we'll use OKHTTP client to talk to our local server. We build our URL. We then use client.newCall to enqueue the request. Change your class to app-compat activity. And import. Then import OKHTTP3 *. Open your build.gradle file and add the OKHTTP dependency. This library is essential for handling our backend API requests securely. Click Sync Now, and now our app can handle web requests. Back in the code. Perfect sync. We implement the onResponse callback. Inside onResponse, we parse the JSON to get the token. And use run on UI thread to call login room. We leave on failure empty because we are testing on a stable local connection. Now set handler. In set handlers, we override on room state update. If the state is connected, we start publishing our stream and tell our server API to start the call. Then, override on room stream update. We check if the user ID contains agent or AI. If it does, we start playing Mara's stream immediately. Then override on rec experimental API for the text accuracy. Wrap this in a try-catch block. First, we perform a triple parse on the content to dig through the nested layers of the ZEGOCLOUD message. Next, we grab the CMD ID to see if the data is for our voice or Mraz response. We then pull the data object and check the end flag. This is crucial because it tells the app exactly when the AI has finished its sentence. Finally, we extract the actual text string. By using OPT string, we ensure the app stays stable even if a packet comes back empty. Now, we use run on UI thread to safely update our user interface. Once the end flag is true and we have text, we clear Mara's buffer and drop your message bubble onto the screen. Actually, it should be Mara message buffer to match her name, but you can name it whatever you want. Just make sure it's exactly the same as the variable we declared at the top. At the top of the file, declare private var Sarah message buffer. We wrap everything in a try-catch to keep the app running smoothly, even if the data format changes. Now CMD4 is for Mara. As she speaks, we append every word to our Sarah message buffer. When she finished her sentence, we display the complete message and reset the buffer. Now, before we create the stop call and end message functions, let's build our second and last Kotlin object file, server API. Inside, we'll define a private OK HTTP client. And notice how Android Studio automatically imports the OK HTTP3 library for us. Next, we write our start call function. We create a JSON object and use .apply to put our data into it. Again, the JSON import is shown automatically. This takes the room ID, user ID, and stream ID as parameters. Now, we convert that JSON to a request body. You'll see the import for to request body and to media type or null appear at the top. If not, import. We build our request using our server URL and the start call endpoint. Import OK HTTP3. In the onResponse callback, we capture the agent instance ID from the server's response and pass it back through our callback function. Finally, we handle the on failure by returning null. This also imports the IO exception automatically. Now back to main activity. Inside our stop call function, we tell the ZEGO engine to log out of the room and then destroy the engine instance. We also find our chat container and call remove all views, so the screen clears for the next session. Next, let's build the end message function. We find our chat container and create a new text view programmatically using .apply. We set the text to our message, set the size to 16F, and set the text color to white. At the top, make sure to import Android graphics color. Now, for the backgrounds, we use setBackground resource. If I am speaking, we use message_background_user, otherwise we use message_background_AI. Let's create these two files first. First, create user message file in drawable folder. Name this message_background_user. Change the root tag from selector to shape. And set it to a rectangle. For color, we'll use a classic blue. Now corners, this is the important part. We set the top left, top right, and bottom left to 16 dp. But leave the bottom right at 4 dp. This creates that sharp tail that points to the user side. We add padding on all sides to keep the text from touching the edges. Now create the second file for a message. Name this message_background_AI. Again, change it to a shape. Copy the code from the user file and paste it here. We'll change the color to a sleek dark gray. And flip the corners. Set the bottom right to 16 dp and the bottom left to 4 dp so the bubble points to the AI side. Back in our main file, let's finish the remaining code. We set our layout params to wrap content. And use gravity to push user messages to the end and Moraz messages to the start. We add some margins and padding for a clean look. And then finally call. To make the experience smooth, we use scrollView.post. This ensures that as soon as a message is added, the scroll view automatically scrolls to the very bottom using full scroll. Now our code is complete, but let's solve some quick typos to make sure it runs perfectly. Move to the top of onCreate. Here, we accidentally declared both as start call button. Let's fix that and make this one the stop call button. Now, back to our Node.js code. Go to your server folder. Right-click on the empty space and select Open in Terminal. In the terminal, type node index.js and hit Enter. It might give you a module not found error. No worries, install the dependencies by typing this. If you get a permission error here, just type this. And hit Enter. Now, run the install command again. Now they are perfectly installed. Finally, type node index.js again. Amazing, it shows server running. Back to Android Studio, open the server API file. And make sure we close this bracket here at the bottom. Because we are running a local server, we need to allow clear text traffic. Right-click on your XML folder, go to New and XML resource file, and name it Network Security Config. Remove the default lines and write this code. Make sure to replace my IP address with your own IPv4 address. Now, open your Android manifest. Inside the application tag, add this line. Also, I noticed server API was accidentally written as an activity. Let's remove that. And finally, add this line to be safe. Everything is now perfect. Let's run our app and see the final result.
I'm doing great. How about you, Hassan? That's awesome. Hope your day stays super lovely. You're like sunshine on a cloudy day. You light up every moment.
She's amazing, right? If you like this project and want to see more, don't forget to subscribe, like, and share this video. Comment below with your suggestions or tell me about your achievement in making your own AI companion. The full code will be on my GitHub soon. Check the video description for the link. See you in the next video.